sometimes one of the questions might come in this way. States the factors that affect the resistance of a conductor or of a wire or a conducting material, so to say. And as a student preparing for exam, you need to know that in electricity, there are factors, electric current per se, there are factors that affect the resistance of the wire being considered. So let's look at that. There are 4 factors. Of course, if we have factors that affect the resistance R of a wire. I'm using all this of a wire. Let's look at that. If we have something like this, just call it wire A, okay? Wire A. And we have another one, wire B, S, that looks this way. Look this way. Look at it. All right? Good. And maybe we have another wire, wire C, that looks this way, very big. All right? All right? I'm going to explain this. I'm going to explain this in a very unique way. Okay, so we're talking about length is proportional to the resistance. Of course, we should know this. And then, the same thing here. But here it means the cross-sectional area. This is the cross-sectional area. The area A, all right? That is it. This is just A. This is just A. Interesting. Can you tell me your observation here? Can you see the 3 wires? The 3 wires are not the same in size. Of course, they have different cross-sectional areas. They're not the same in size. So I want to tease you a bit. What do you think? Which of them do you think we have high resistance and low current? And which of them do you think we have low current, we have high current and low resistance? Take it again. Which of the 3 wires, wire A, B, and C, do you think will have high resistance, low current, or high current, low resistance? So let's see. Let's see. Interesting. But that's not our concern. Our concern is to explain the factors that affect this when it is connected in an electric circuit. Now, look at the nature of the wire is different as well. So if we have, number 1 is the length of the wire. The length of the wire is a factor that also affects the resistance of the wire. All right. Number 2, we have the cross-sectional area of the wire. Cross-sectional area of the wire is also another factor that affects the resistance of the wire. The third factor is the, what do you think? What do you think is the third factor? Because we have about 4 factors. The resistivity of the material. The resistivity of the material, right? Yeah, resistivity of the material, represented by Greek word rho. Then I want you to tell me the 4th one. We have mentioned length, cross-sectional area. What again? Resistivity. The 4th one is what? Can you tell me the 4th factor that affects the resistance of a wire? All right? Can you tell me the 4th factor that affects the resistance of a wire? And the 5th one is, what connectivity do they have? What is the formula for the resistivity? Put it here. All right? Yes, let me push a bit. I know you were expecting me to mention all the 4 factors. Of course, I've mentioned the first one, length, cross-sectional area, right? And resistivity, the fourth one. The fourth one is something you know. So what is Ohm's law? Let's start with that. What is Ohm's law? Ohm's law states that the current flowing in a metallic conductor is directly proportional to the applied voltage or the potential difference across the two ends, provided other physical factors remain constant. These are the physical factors that must remain constant. These, by the time you complete the fourth one, these are the physical factors that must remain constant for Ohm's law to hold. And that Ohm's law is given as, Ohm's law is given as V is equal to IR. Can you see that? Resistance is mentioned there. Okay, I will leave it at this point. And I urge you, go and supply in the comment section the fourth factor and the connection, the formula for finding resistivity. By the way, what is the meaning of resistivity? It tells us the nature of the wire, the material, the substance used in making the wire. That's what it tells us. So be confident in answering your question in exam condition like this. I sign out this moment. See you.